Hi everyone. So now we'll see classification of numbers. This is a basic topic, but then a lot of weightage is there in the exam because of the fractions, rational, irrational, real numbers. So the wordings are important, or the nomenclature. So first we'll go through the basic definitions. Natural numbers, whole numbers, and integers, right? So natural numbers, most of you would be aware, they start from 1, 2, 3, 4, so on up to infinity, right? So 1 is the first natural number. The next one is whole numbers. Whole numbers is natural numbers plus 0. So make sure you all write this definitions. Integers is, this includes both positive as well as negative integers. And so on. Okay, next important definition is rational numbers. So the definition is set of all numbers that can be expressed in the form of P upon Q. Okay, so where P and Q are integers. Okay, that means they can be positive as well as negative, but with a condition that the denominator cannot be equal to 0. Why? Anything divided by 0 is not defined. Right? The denominator cannot be 0. So that's why any number of the form P by Q and Q not equal to 0 is the definition of a rational number. So as you can see some examples here, 12 upon 7, both are integers, positive. Negative 3 upon 5, one of them is negative, and both are integers. 6 upon 1. Yeah, remember even the integers are rational numbers. Let's say if I'm saying 6, I can always write 6 as 6 upon 1. This is P and this is Q. If there's nothing in the denominator, there is 1 in the denominator always, which is an integer. So remember, all the integers are also rational numbers. Okay, now we see a decimal, right? 2.9. How can this be a rational number? Definitely 2.9 we can write as 29 upon 10. We'll look into decimals in the later part a bit more. But this can be written as, since there is one decimal, we can divide by 110, right? Now, how did we get it? We can multiply and divide by 10 to this 2.9 and multiply the numerator 29 and 10. We'll see in detail of this in the later series. Yeah, so remember, any number P by Q or even the decimals can be converted into P by Q form. They are rational numbers. This is the first definition. Now the second definition, this can be a bit tricky to understand. All the recurring decimals. Now to understand recurring, first we'll need to understand what is terminating. There are two types of decimals. Either they terminate or they recur. Terminating is what we have seen, 2.9. The decimal terminates. Now recurring is, let's say, 2.9 bar. This is how we represent the recurring ones. That means 2.9999, so on, right? So this is recurring, this is terminating. Now even the recurring decimals, they are rational numbers because even they can be expressed in the form of P upon Q. Okay. Now, how do we find out their values? Remember, so most of us would be clear or know this, the value of 1/3 is 0.3 bar, right? Just 0.333, so on. So this is a good starting point to recollect that yes, recurring values, which is 0.3 bar, we can write it in the form of 1 upon 3. Now the question is, can we write any recurring decimal into p by q form? The answer is yes, we can definitely write. Now how do we write that? We'll see a bit later. Okay, so all of this, how do we get to these values? We'll see a bit later in the next slides basically. But remember, any recurring decimal, right? All the recurring decimals can be expressed in p by q form. There is no exception for this. Okay. Now the next one is irrational numbers. Obviously, if any number of the form p by q is rational, any number which is not in the form of p by q is irrational. That you cannot express in the form of p by q, right? Typically, all the surds or radicals, we say square root of 2, square root of 3, cube root of 5. That means which cannot be solved, right? Square root of 2 is approximately 1.41 something. So now this does not stop, this does not recur, because if it recurs, we have seen that it has to be a rational number. So what is irrational? Something which cannot be of the form p by q and something which does not recur, right? Now important to note, let's say square root of 4. Is this irrational? Obviously the answer is no, because this solves, right? This solves to 2, which is of the form p by q. So this is not irrational. Now let's say if I ask you cube root of 27, is this irrational? So 27 is 3 cube. So this 2 gets cancelled. We know that cube root of 27 is 3. Again, this is not irrational. So something which does not solve is irrational, which solves is not irrational. So whenever, be careful, whenever in the exam they give of this form, first try and simplify and then see whether it is rational or irrational. Now this is important, pi. Pi is irrational because the value of pi is some decimals and it does not repeat. Okay, there's a misconception that pi is equal to 22 upon 7. If it is equal to 22 upon 7, then this has to be rational, right? But this is approximately equal to 22 by 7, not exactly, right? So hope the definitions are clear for rational and irrational. The next one is real numbers. So what is real number? Basically rational and irrational both. Okay, any number is real basically. So this is a definition, not very important. Any number that can be expressed on number line. Number line we have we'll see in the later parts is basically the x-axis, right? Is basically the x-axis, that is number line. We'll discuss in detail later. Okay, so I've told we'll see a bit of rational numbers, right? How to convert recurring decimals to p by q form. Now typically this is, everyone knows this, and most of you would be knowing this also. 2 upon 3 is 0.666, so on 0.6 bar. Okay, now how to write, let's say if one decimal here, one digit, right? 2 is the digit which is recurring. So if you have to write this recurring decimal into p by q form, remember this is if one digit recurs. This is the case where one digit recurs. So you will write that digit upon 19, because one digit is repeating. You will write in the denominator 19. That is the value of 0.2 bar. Now, how do we know this 0.3 bar is 1 upon 3, right? How did we get? So the value of this is one digit repeating. Write the digit upon 19. So this simplifies to 1 upon 3. The same way you can see 0.6 bar is 6 upon 9, which is 2 upon 3. Okay, so that way 0.7 is 7 upon 9 and so on. I hope this is clear if one digit is repeating. Now, what if two digits repeat or recur, right? So the example we have taken, if 0.23 bar, okay, the value of 0.23 bar, now you will need to write two digits, and instead of 19 you will write two nines, because two digits are repeating. It's simple as that, right? So let's say 0.55 bar, okay, it's just 55 upon 99 or 5 upon 9, right? Because 0.55 bar is nothing but 0.5 bar, which is 5 upon 9. Okay, now the same, if three digits repeat, one more 9 has to come here. 0.317 bar is 317 upon 999. Okay, I hope this is clear how to convert the recurring decimals or the repeating decimals into P by Q form. Now there are some miscellaneous, right? Now what happens, instead of 0.3 bar we have something like 0.023 bar. Now one way to remember is you write the same, because two digits are repeating, you write those two digits and two nines, and the number of zeros here, they will be added in the denominator. This is a shortcut. Now let's say if two zeros are there, so what will you write? The value is 23 upon 99, but then two zeros will come, these two zeros. Okay, this you can remember as a shortcut. Why? Because of this 0.023 bar is 0.23 bar divided by 10, and we know 0.23 bar is 23 upon 99 divided by 10. So this 10 will go as 1 upon 10, basically the reciprocal, so 23 upon 990. And the last one is 1 point, let's say 1.23 bar. So first what will we do? We will kind of separate this. Okay, so this is 1 plus 23 upon 99. So if you are clear about the LCM, so 1 into 99 plus 23, which is 99 plus 23 or 122. Okay, we split the integers as well and the fractions or the recurring decimals, and then we add them. Okay, we'll solve few more questions of this. Express the following in P upon Q form, right? So the same way 1.2 bar I will write as 1 plus 0.2 bar. So this will be 1 plus 2 upon 9. So basically the same denominator, take 9. So in the numerator I have 11 and denominator, right? So this is P upon Q form. Okay, you all can try, pause the video and try. Okay, so 0.031 bar. Now the important thing is to separate the recurring part and the remaining part. Now we can see that only one is recurring, right? So how do I write this? 0.3 plus 0.01 bar. So for example, how do we separate 0.24? 0.2 plus 0.04, right? So when we add this, we get 0.24. So I hope this is clear how to add. We'll discuss about this also in the later videos if you are not clear of this. Okay. Now 0.3, we have seen it can be written as 3 upon 10, one decimal. Now 0.01 bar, one digit is repeating, so I will essentially write 1 upon 9, but because there is a 0 here, right, we'll add this 0. We have seen 0.023 bar example. So this is 3 upon 10 plus 1 upon 90. Again, we'll keep the same denominator, so I'll multiply and divide by 9. That will bring me 27 upon 90 plus 1 upon 90, which is 28 upon 90. So both are even. This can be further simplified in two tables. So the value of this is 14 upon 45. Make sure you all make a note of all of this, right? Okay. If 14 upon 11 is equal to 1 point AB, AB, AB. So how can I write this? 1 point AB bar. Two digits are repeating. Then find the value of A plus B. Okay. So one way is we do the actual this thing, long division method, right? So that's a straightforward way. 11 ones, 11. We have 3. This doesn't go, so we'll need a decimal. So 0 comes here. So this goes 2 times. 11 twos are 22. Then 8, 1 0 comes. Then 7. Yeah, 77. Then 3 comes, 0. Again 2. So as we can see here, 2727 is repeating. And so on. So the value of 14 upon 11 is 1.272727, so on. So A is equal to 2 and B is equal to 7. So we can compare, right? 27, 27, 27 and so on. So the value of A plus B is 9, which is option number C. Okay, so one last question. Find the 17th digit to the right of decimal point in the decimal form of 23 upon 37. Okay, this is a bit tough. Probably will need to do long division a bit more. So we'll need to begin with a decimal. Okay, now either I try 6 or I try 7. I'm just guessing. 6 sevens are 42. 18, 6 3s are 18 plus 4, 22. Okay, yeah, this works, right? So with hit and trial, we'll get to this. So we get to 8 and a 0 comes. Then this I think goes 2 times. 37 fours is 74 and a 6 remains. A 0 is there, so this will go in 1. 37, so 23. Okay, so we got to the same, right? So what's happening here is basically these 3 digits are recurring. So the value of 23 upon 37 is 0.621, 621, 621, so on. Now we want the 17th digit, and we know that 3 digits are repeating. So these are 3, these are 3, these are 3. So 9 are done, 3 more, 12 are done, 3 more, 15 are done. So we want 17th, right? So 6 to 1, this is 16th, and this is the 17th digit, which is 2. Okay, so the basic normal long division, we will be able to get the answer. I hope this is clear, and we'll see you in the next video. Thank you.